Continuing on with our 5.4 lesson on factoring, now that we know the AC method, we're going to want to apply it to our example here. Now remember, the first thing to always do is to check and make sure, or to see if we can do factor by greatest common factor. And it looks like all of these we have the 3y squared, negative 2y, and negative 5. Well, they don't all have a y factor in them, or a y term, so we can't pull a y out. And the coefficients of 5, 2, and 3, those are all prime. So none of those will match up with each other. So we can't pull the greatest common factor out, so we go directly into our AC method, which means we first have to define A, B, and C. A in this case is 3, because of 3y squared. B is negative 2, and C is negative 5. Now that we know A, B, and C, we need to find A times C, or AC, which is going to be 3 times negative 5, and that is 15. Now remember, when we have AC, we need to find what the factors are. And we want our factors to add up to B, which in this case is negative 2. We also need to remember that our AC is negative. It's negative 15. So whatever we find for the factors, one will be positive and one will be negative. So the factors of 15 would be like 1 and 15, or 3 and 5. Again, remembering one being positive and one being negative. So if we look at 1 and 15, and we said that 1 was positive and 15 was negative, we'd be left with a negative 14. But if 1 was negative and 15 was positive, then we'd have positive 14. Neither of these are negative 2, so those are not the ones we're looking for. We have 3 and 5. Let's say that 3 was negative and 5 was positive, in which case we'd have 2. But if 3 was positive and 5 was negative, we would have negative 2. And the negative 2 is what we were looking for B. So we know that that was when 3 was positive and 5 was negative. So those are the factors we're going to be using. Now from here, we again make our table of this column is going to find our y terms. And we do that by looking at the factors of A. In this case, A is 3. In this column, we're going to find our constants, and again, remember, these are from our binomial factors. Our constants we find by looking at the factors of AC, so 3 and negative 5, and we need all of those to multiply and add up to C, which was negative 5. So looking at our y terms, we need the factors of 3, or the factors of A. Those are just 1 and 3. And we need to match those with the factors of AC. So we have 3 and negative 5. And since one of our factors from A is 1, we mainly just want to look at 3. Now looking at our factors from AC, we have 3 and negative 5, and we know that negative 5 is not going to divide 3, at least not evenly, so we want to make sure that we pair up 3 with 3, in which case then we would match up the negative 5 with the 1. Now when we divide 3 from over here with 3, that leaves us with 1. And when we divide 5 by 1, that leaves us with negative 5. And when we multiply that 1 by 5, we get negative 5, which was what we were looking for. So we know that these are the right ones to use, which tells us that in our binomial factors, our y terms are going to be 1 and 3. So we're going to have 1y and 3y. And our 1 needs to be paired up with negative 5, and our 3 needs to be paired up with positive 1. And again, by pairing up, we mean that they need to multiply. So 3y needs to be multiplied by positive 1. We put it on the other side so that when we FOIL, those ones will be multiplied together. Same thing, our 1y needs to be multiplied by negative 5. So we put them on the other side so that those ones will multiply together when we FOIL. So, speaking of foiling, we're going to do that just to check, make sure that these are correct. We have y and 3y, which makes 3y squared. Y and negative 5 is negative 5y. 1 and 3y makes a positive 3y. And 1 and negative 5 gives us negative 5. Our 5y and our 3y combine to make negative 2y. So we have 3y squared minus 2y minus 5 which was our original expression there. So we know that y plus 1 and 3y minus 5 are, in fact, our binomial factors. So, moving on from there, that was our first example. Now, if we wanted to look at our second example here, we have 5m p squared minus 45m. The first thing, remember, we want to do is always see if we have a greatest common factor. And it looks like in both cases we have a 5 that we can take out of the coefficients, and we also have an m to the first power. So if we take out 5m first, that would leave us with p squared minus 9, because that's going to be what's left, 5m p squared minus divided by 5m, and negative 45m divided by 5m leaves the negative 9. So now we have it to 5m times p squared minus 9, but we're not quite finished. Remember, if we go back and look at our table, the p squared minus 9 is in fact in the terms of our difference of two squares, a squared minus b squared. Our a in this case would be p, and our b would be 3, because 3 squared is 9. So in this case then we have to factor the p squared minus 9 down even further. So we'll leave our 5m that we took out from before, but we have to make more factors from our p squared minus 9, and those ones are going to be p and p out here, because we had our a and our a, and then we had a plus b, so plus 3, and a minus b, so minus 3. So in this case, now we have it factored as far down as we can go. So in the end, our factor is going to be 5m times p plus 3 times p minus 3. So again, first thing to look at is the factoring by greatest common factor. Then once you have it down into a smaller polynomial, see if you can factor that anymore. And this is our final answer. Moving on to some of our other examples. If we look at our x cubed, y cubed plus 8, that's of the form of a sum of two cubes. We have xy cubed and 2 cubed as our a and our b. So actually we can just write that out. Xy in this case is our a, and 2 is our b. So we need to put it, we have the a cubed and our b cubed, a cubed here, b cubed here. So we just need to put it in the terms of a plus b times a squared minus ab plus b squared. So that's going to be put into the form of a, which was xy, plus b, which is 2. And then it looks like we need a squared, so xy, each of those squared, minus ab, so it would be 2xy, that's a times b, plus b squared, which if b was 2, 2 squared would be 4. So this would be our factor. And again, to check, we'd have to, it's going to be similar to foiling. It's basically just going to be a double distribution. We're going to have to go xy times everything in our second one here. And then we're going to have to go 2 times everything inside here. So if we do our xy first, xy times x squared y squared will leave us with x cubed y cubed. Xy times negative 2xy leaves us with negative 2x squared y squared. And xy times 4 plus 4xy. Now if we look at 2 times our x squared y squared, we get plus 2x squared y squared. 2 times negative 2xy becomes negative 4xy. And 2 times 4 is 8. Now from here, we notice that we have a negative 2x squared y squared and a positive 2x squared y squared. So those will subtract out. Also, we have a 4xy and a negative 4xy. So those will subtract out, in which case the only things we have left are x cubed, y cubed, and 8, which looking back was our original expression. So again, in this case, xy plus 2 and x squared y squared minus 2xy plus 4 are our factors. So this would be our final answer. Moving on from this one. If we look at our last example here, this one is in terms of a difference of two cubes. We have 64x to the 6th minus y to the 6th. So in this case, it looks like our a, again, we're asking what is going to be cubed here. So this one is going to be 4, because 4 cubed is 64, x squared, because x squared cubed is x to the 6th. So a is 4x cubed. Our b that we're looking at, remember b cubed is going to be this one here. And so our b is going to be y squared, because when you cube y squared, you get y to the 6th. So now that we know our a and our b, again, we just plug it back into our trick here, plug it back into our form. So we know that our factors are going to be a minus b. So a is 4x squared minus b, which is y squared. Now we need a squared plus ab plus b squared. Well, a squared is going to be 4x squared squared. So it would be 16x to the 4th, because 4 squared is 16, x squared squared is x to the 4th. We need plus ab, so it would be plus a, which is 4x squared, times b, which is y squared. And then plus our b squared, so it would be plus y to the 4th. Remember, b is just y squared. We want b squared. And y squared squared becomes y to the 4th. So it looks like these would become our factors, but again, we want to check just to be sure. So we have to do, like we did before, kind of that double distribution. So we have to do 4x squared times all of this as 1, and then we'd have to do the negative, oops, I want that in blue, negative y squared times everything as well. So we'll start with the 4x squared times everything. 4x squared times 16x to the 4th. 4 times 16 is going to be 64, and x squared times x to the 4th gives us x to the 6th. Now 4x squared times 4x squared y squared gives us a positive 16x to the 4th. Oops, I wanted that in red. And then y squared. And 4x squared times y to the 4th gives us plus 4x squared y to the 4th. Okay, now we need to look at all of our negative y squared multiplied by everything. So negative y squared times 16x to the 4th is going to give us a negative, because the y has the negative out front. Negative 16x to the 4th y squared. Negative y squared plus 4x squared y squared. I'm going to go down one here. That's going to leave us with negative 4x squared y to the 4th, and negative y squared times y to the 4th. and leave us with negative y to the 6th. Now when we're looking at these, this looks like we're at the end, but we do need to combine like terms. We have the x to the 4th y squared term, which is also right here, and both of these have a coefficient of, this one is negative 16 and this is positive 16. So these ones will subtract out. Similarly, we have a x squared y to the 4th term. Maybe I'll do that in a different color. X squared y to the 4th and x squared y to the 4th. One has a coefficient of positive 4 and one has a coefficient of negative 4. So those ones will subtract out. And like last time, we're left with just the 64x to the 6 and negative y to the 6, which is going to be the same as our original expression. So we know then that our binomial factors truly are correct, and this would be our answer.